Hello. Hello. Good afternoon, everyone. Can everybody hear me? Hello. Okay. So is it clear? And also, is that okay for the screen? Okay. So can everybody look clear about my share screen? I think it's only the PowerPoint. Okay. Thank you. Okay. Thank you. So then, yeah, then we just have a very quick review about what we learned last week. We talked about those how we utilize the combinations table and also the equation to really calculate those equivalents between different kind of the cash flow. And so that you can now know that, okay, if the target is a present value, then we can now utilize some equation to convert it, the annual value about A and to the present, and also the future to present. And then if you also would like to calculate it for the annual cost or annual benefit, the same thing that we can do is that we just converted all those kind of cash flow from present value, future value to annual value. Okay. So, and then not only talk about how we calculate that, we also demonstrated some of the example to compare different alternative and using the present value, right? The present worst method. And then remember that using present worst method is that we need to use the at least common periods that the useful life for those alternatives so that they are comparable. So it is nonsense that we compare with a different alternative with a different useful life, right? And then, but another thing is that we also talk about annual cost and annual benefit, that then we don't really have this kind of limitation. We can just convert it, those kind of cash flow into the annual basis so that those alternatives can be compared, right? So that this is what we have from the last week, right? But then other than that, actually there are also other I would say other methods to really compare different kinds of the alternative. And this is one that will continue today, is that we call it internal rate of the return, the IRR. Remember that for those kind of calculation, whatever is P, A, and F, right? And then the I is always, the interest rate is always like the given information like to you, because whatever is MERR, discount rate or whatever, it can be just seen as an interest rate. So, and making those equation comparable and making those alternative comparable, right? But then how about that? We have other kind of information already, but the unknown is the interest rate. Then this is something that we want to talk about now, that this is called the internal rate of return, which is the discount rate that makes the net present value equals to 0. Okay, so think about that. Then we have so many different kind of alternatives, right? But then we put it, the present worst method, like those present value into 0, and then the IRR is unknown. Then this is what the things that we want to find today for this internal rate of return, all right? And then this IRR indicated the real profit level of a project, so that we can set up this NPV as a 0, so we can really know that, okay, what will be the profit level of the project. So a profitable project should have an IRR value greater than MARR. Remember, we also talked about MARR last week, is that different company, they may set different kind of NR depending on that they take into account all the costs, not only about direct costs, but also indirect overhead, administrative costs, like those kind of things, so that they will have the MARR, means that they will can define that this project should be higher than the MARR of the company, so that this project can be seen as profitable. So a project with an IRR value equal to MARR is not considered profitable to the organization. It should be higher. So the project with an IR less than MRR should be rejected. So that we were gonna continue with this concept with the example 10. Now we have 3 available projects that commencing in January 2005 and ending in the December 2014. And annual discount rate is like 12%. Okay. So that if we have those kind of information, we can see that here, table 1, we have the summary of the investment plan. And the project A, we have initial investment 2,000, salvage value 500. I think some of students also asked me about what is salvage value. Remember, now I would like to remind again, this is kind of future value. Okay, after this kind of initial investment, think about that is in equipment. And then for the those initial investment, you were gonna sell this equipment and we get some money back. This is we so-called the salvage value. Okay, so like kind of like remaining value from your asset or from your investment. And then for this example, we will also not only talk about the cost, we also have to consider about the net annual profit. Okay, so this cash flow, yeah, of course, will be more complex compared with the previous example that we have last week. And then so for the project B, we have the initial investment 3,500 and the salvage value 600. And then D here, the net annual profit is also a bit complicated here, that from the year 1 to year 5, it will consistently earn the 480 for the profit of the project B. But the year 6, you will have the 750 and an annual growth rate of the 6% from the year 7 onwards. Okay, it's kind of like constantly grows from the year 6. Okay, and for the project C, the initial investment is 4,000 and the salvage value is 0, but it has a net annual profit from year 1 to year 3 as 700, year 4 to year 7 is like 750, and the year 8 onward is 800. So now here, like I said, always say for these kind of questions, that the first thing that I would suggest is just like draw the cash flow diagram. And then now you can also use the NPV method to access the 3 plans. Okay, because that now you know the annual discount rate is 12%. So you have all the information. And then these 3 project, of course, they are comparable. So how can we do that? Like I mentioned before, that we can draw the cash flow diagram. And this is for the project A. Initially, that we have the initial investment 2,000, right? It's the quite long downward arrow. So we have 2,000, and then we have the upward, which is the profit of each year. From year 1 to year 10, we get the 350 constantly for these 10 years. And then we also have the salvage value in the future. After 10 years, we get the 500 back. So simply say, based on what we learned last week, we can calculate the net present value as negative 2,000. Now, remember that what we want is not the cost. Now we set the base is the profit. So that is why we have the negative 2,000 and plus the 350 times the bracket of the P8, 12%, 10, right? Because now we want to convert the A to the present value, because the A, this project constantly earn the 350 for the following 10 years. So we can do this like 350 times the bracket of P8, 12%, 10. And also we convert the salvage value from future value back to present value. Now it's 500 times the bracket of the PF, 12% and 10. All right. So that, yeah, I assume that all of you now know how we can utilize the compound interest table. And then so we can directly find the value like this. We have negative 2,000 plus 350 times 5.65 and plus the 500s times the 0.322. So you can look at about that. We have initial investment, but the following 2 parts are profit. So that we have the NPV for the project A is equal to 138.5. So project A should be economically attractive because that the profit is higher than the cost. The NPV is larger than 0. right? So that if we look at about this, we use the NPV to make the decision making, then this project A is profitable, is economically attractive. All right, so that's a good. Any question about that? And then, so then the next one, yeah, this one obviously is a bit more complicated, since that they have a different kind of the cash flow during these 10 years. So initially that we have the downward for the investment for 3,500, and we constantly can earn 480 for the first 5 years. But then it will gonna be increased from constantly from year 6 to year 10. Actually, this is the part that we can use from the compound interest table for that G. Remember that there is the capital G, but we didn't really discuss this because yeah, this one is also quite complicated. So I didn't really use that. Instead of using the G note, I just show you that, okay, we just take these 6% for the each from the year 6 to year 10, and we let it become the future value, so that it will be easier to understand it, that we can convert it from the year 6 as a future value, year 7, year 8, year 9, and year 10. Like the future value converted them back to the present value. So that you can see here is how we calculate it. We have the negative 3,500 and plus the 480 times the bracket of the PA, 12%, 5. This is for the A part, right, from the year 1 to year 5. And then we can plus this 600 plus times the bracket of the PF, 12%, 10. Okay, this is the salvage value. And then we started with to counting the year 6, like 750 times the bracket of the PF, 12%, 6. And plus the 750, okay, times the 1.06, because yeah, this is the question information that gave us that we have the 6% increased growth for the following years. So we have this one, and also times the bracket of PF, 12%, 7, and also plus the 750 times the bracket of the 1 plus 0, 6 times to the power of 2, and times the bracket of PF, 12%, 8. And then plus, yeah, it just like will continue this kind of similar approach from the year 8 to year 10. And then you can finally find that, yeah, we will get the answer as the NPV of the project B is 130.49. Okay, so the same, like project A, actually, this is the NPV is also larger than 0, means that the benefit is larger than the cost. So the project B should be also economically attractive. All right, so this is for the project B. So that's good. And then so for the project C, yeah, it also has constantly income, like the benefits, but it just like have different kind of the section, like the like from the first part, from the year 1 to year 3 is 700, from year 4 to year 7 is 750, and from the year 8 to year 10 is 800. So this is so what we can do is like this. I think if you are not really familiar with all these kind of calculation for the equivalence, then you may also take a look at here. Then you can find that what we have the solution here is like the negative 4,000, of course, the same like for the initial investment, but then also plus this benefit from the year 1 to year 3, we have the 700 times the bracket of the PA, 12%, 3, and also here we have this 750. This is the second part that we want to calculate from year 4 to year 7. So we have 750 times the bracket of the PA, 12%, 4. But we also need to convert this part because remember, here when we do the PA, 12%, 4, we converted those year 4 from year 4 to year 7, this 750 to the beginning of the year to the end of the year 3. Remember that, because we were gonna convert it not directly to the present value. Actually, this is the converted to the year 3. All right, because for this PA, 12%, 4. So that we need to times another conversion, that because this A from year 4 to year 7 will become the F after year 3. Okay, year 3. So then we will need to times the bracket of the PF, because from this F, from the future value, we need to convert it again back to the present. So we need to have this PF comma 12% comma 3. Clear? So that the same thing that for the cash flow from year 8 to year 10, we also do the similar thing, that we have 800 times the bracket of the PA comma 12% comma 3. Okay, again, then this value actually converted this 800 from the year 8 to year 10 to the year 7, all right? And then it becomes the future value, okay, instead of the present value, so that we need to also convert this future value, like times this bracket of the PF comma 12% comma 7 back to the present value, so that this is what we can do, and for these 3 parts of the A, all right? So that we can get finally like negative 4,000 and plus the 700 times the 2.402 and plus the 750 and times the 3.037 and times the 0.711A, and also plus the 800 times the 2.402 and times 0.4523. So we get a final present value is the 171.84. And yeah, you can see that project C is also economically attractive. Okay, if we just use the NPV. However, we haven't really considered that, okay, the MARR of the company. Okay, also that we know that those projects, if we spend the direct costs for that, it will be make these old projects economically feasible. Right, but however, if we also put in those indirect costs, the maintenance costs, and all that kind of thing that for the company, we need to make sure that whether these kind of income, these kind of benefits will be also economically feasible when considering those kind of other factors. So that is why we were gonna compare these IRR and MARR things. Okay, in the solution, the question part B. So then for the project A, now we will set up this NPV equal to 0. Remember that now we didn't really want to calculate NPV. Instead of that, we will set it up to 0. And then the equation actually will be the same thing. So we have the negative 2,000 plus the 250 times the bracket of the PA comma I percent comma 10 and plus the 500 times the bracket of the PF comma I percent comma 10. But then now it's equal to 0. Okay, so then now if you are good at use of your engineering calculator, and of course that you will get the I percent, like this internal rate of return is 13.53. Okay, but if you are not really good at that, if we would like to use the compound interest table to calculate that, then I would suggest it how we do that is that we just use a range and then using trial and error and also plus the interpolation. For example, you can guess that this I percent, because you already know that the discount rate is around 12%. So then we can set up, for example, 5. If this is 5%, then we will gonna get the NPV, will be equal to some certain value, right? And then, but it probably will be negative or positive. It will be setting up some range. So if now it's the 5%, and another one, if you guess, is like 50%, or you can set up 12%, or even larger. So you will gonna get the positive another value for this. Okay, of course it won't be 0, but this is kind of like trial and error that we can do. So that we will get a 2 value. And then 2 value, instead of that, then we will gonna guess, for example, if this is the negative 1,000, and then you will gonna have the range from negative 1,000 to 0. And if it's positive value, then we will also get another kind of range. So we can use the interpolation so that we can also set up these kind of things to get the IRR or the I percent, and which is equal to the 13.53%. Okay, so that for the project B, the same. We just set up all the equation the same, and then we equal and let it equal to 0. Then we will gonna get the IRR the I%, which is equal to 12.74%. And project C will be 13.01%. So if we look about this one, if the MARR, what we said is 13.5%, and actually only the project A is worth investing. Okay, only the project A is worth investing because it is a bit higher than the MARR equal to the 13.5%. All right, so that's good. Okay, if you are not familiar with that, how we can do the interpolation, then for today, we also have some of the practice that you can do the this kind of IRR calculation, and will be also simpler than this one. And this one for the IRR, yeah, a bit difficult. Okay, but then for the tutorial part, it will be much easier to solve. Then you can try it later. All right. So then we just finish the part that we couldn't finish last week. Then we will continuing another part. Yeah, it is still the economic appraisal, but we will gonna also talk more and include more details. Okay. Yeah, actually, there is a student asked that, okay, if the NPV have the highest value among the option A, B, C. Yeah, I'm still, but I just want to answer a question from the students. So that which option should be chosen if the MAR is set up to 12%? Okay, so usually if we do that, we will still choose the one with a higher NPV value. Okay, if we will still choose a higher NPV value. All right, but the internal rate of return is that just want to let you know that there are actually other kind of factors that we need to consider for making such a decision making. Yeah. So wait the. Yeah, actually, we will also talk even more for how can we do the decision making. Yeah, for based on this kind of value. All right. So okay, then now this is the second part of the economic appraisal. Since after you understand it, how we can really do those kind of calculation. And here we were gonna bring more deep and then also consider something more real. Yeah, for example, like from theoretical part, of course, that those calculations is not we cannot really ignore it. But if we really want to do something decision making in real life, actually there are other kind of things, more things that we really need to consider, right? So that this is one thing and very special, and then we call it depreciation. And then everybody actually really need to know what is that, and then this will definitely also take into account consideration for the cost estimation. All right, so that we were gonna spend probably around 30 minutes to really talk about this, and we were gonna do further that, okay, how can we really take this depreciation account and then to do the cost estimations of those construction equipments, okay, especially for the infrastructure projects. So depreciation can be divided as the loss in value of the construction asset over a period of the time. Right? Think about that. For example, like those cost example that we mentioned, that we have the initial investment, right? But we also have the sales value. But why? I mean, why those kind of asset? For example, like those equipment, initially we pay $1 million. But after 10 years, why it only can be sold as like 1/10 of the value or even less? Because this is because that those kind of asset we will kind of cost by different kind of reason. For example, the equipment may get some wear, deterioration, obsolescence, and even like the reduced demand. So there are different kind of reasons why your assets just decrease the value. Okay, so the same thing, like your mobile phone, your laptop, your, I would say, those kind of electronic devices, when you pay something very new in the very beginning, right? Actually, those kind of value will gonna decrease, will be lose, like while you are using, right? So this is so-called that the depreciation, and then depreciation will caused by different kind of reason. For example, the wear is kind of like accumulated as a function of the hours of the use, like severity of the use, and the level of preventive maintenance. Okay, for example, like each hour of the wear on the moving part of an engine. For example, if you have motorcycle, if you have the car, while you started to drive it, the engine will getting older and older, right? So usually an engine of those kind of private car is probably, I would say, 300,000 kilometer, something like that. Yeah, of course, that you will certainly see those kind of very, very old car on the road. But it's just like to talk about, this is kind of like how we define it, a useful life of an engine. So that when an engine started use, when a car started drive, and then you will, of course, started approaching the end of the useful life, right? So that this wear will, of course, cause this depreciation because the engine will getting older and older. Okay, but of course, this is not only one reason that causes depreciation. And how about deterioration? Okay, like gradual decay, corrosions, or erosions of the property, and which occurs as a function of the time and severity of the exposure conditions. Okay, so for example, a car can be like this. It still looks pretty new, but the engine has been heavily used. For example, some rental car in United States or in Australia, because that that all the people live there, they need a car. Or otherwise, it's very difficult to really take any kind of public transportation or walking distance to somewhere. So they need to have the car. So that if some traveler or business guy visit somewhere, they must rental those cars. So those cars can be like heavily used within like 3 years. So 3 years for a car, the exterior of a car can still looks pretty new, but the engine can already be used like 100,000 miles or something like that. So, however, for this kind of deterioration, so the car for those based on that, it will be much depending on the wear. Okay, like the salvage value will much depending on wear, but the deterioration, of course, will also cause for that. For example, if some car has a car accidents, okay, if a car accident, then of course that it will have the record, and then nobody really want to buy this kind of car, right? Because the main structures of the car, the body of the car may already be damaged. Okay, so it's not that safe. It's no longer that safe. So that this will be also cause depreciation because it loses the value. Okay, but how about that? If we forget about the car example, now we take into account about if you want to buy, I don't know, because probably seldom people buy the used mobile phone. Okay, but how about that if you want to sell your phone, okay, to whatever, to a store or something like that, to an agent, and then do you think that they were gonna check it? Okay, how many hours you use for your phone? How long have you been using your phone? Or they were gonna check it whether your phone has some corrosion, erosion, or deterioration. I think that this one will be much important, okay, compared to those kind of I would say daily life electricities, right? Because if it looks new, I think the second-hand buyer won't really bother that. Okay, even that you use it 24 hours per day, okay, to run your phone, right? So then, but similar to the wear depreciation, because then if you didn't really have the well maintenance of your asset, of course, it will cause a lot of depreciation. You will lose lots of the money, right? So then it will also occur whether or not the property has moving parts in the actual use. Okay, so does that, okay, we come back to the car example. So if a car like you always park outside of the street, probably there's raining, heavy wind, or even that some pedestrian just like try to break your car. Yeah, I mean there are so many other kind of uncertainties that just like if you didn't really store your car well, park outside, compared with a car parked in the car park. Okay, of course that one will be much better exteriors and looks much better, yeah, compared with the car parked outside, right? So then this you will gonna well maintenance where how you preserve your asset will also cause these kind of differences of the depreciation. All right. So then also the obsolescence. It is kind of the reduction in value and marketability of the product due to competitions from the newer and more productive models. Okay. Yeah, so that is why that those car manufacturers, they need to have new models, new engines every year, and also, yeah, mobile phone, Apple, Samsung, Sony, they need to have a different kind of model. They have flagship model promoted every year because if they didn't do that, their competitor will have newer and more productive and new style things, right? So even that you are compared with some mobile phone like in the same brand, okay, probably the newer model will just look different, more stylish. Okay, compare for example iPhone 11 and iPhone 12, it looks totally different. All right, so that yeah, some may just prefer yeah I want the newer model, so that the older model, of course, it loses this kind of the value to do marketability. Okay, so what can they do? All right, so they just say, okay, then I would reduce a bit the price and then to keep sell it. Okay, so this is also why that when they announce a new phone, they need to have some events and show, okay, this new phone we have the more power, cheap, and like for example, 50% more faster than older model. Okay, also I doubt that the consumer can really feel that the differences. Okay, unless you really compare with the phone that you bought like 5 years ago and now. Okay, but yeah, it's just like very small differences if you compare the newer model. So then it can be like technological obsolescence, which usually can be measured in terms of productivity, what I just mentioned about the performance of the chips or something like that, or the horsepower of the engine, something like that. And the style obsolescence, like which occurs as a function of the customer taste. Okay, so yeah, I think most of people they just want to have the newer model. Okay, so this is how cause the differences. All right, and so you also kind of reduce demand is like the result in the decreased value of an asset in accordance with the market law of the supply and demand. All right, so that it can be general like business recession, like for example. That yeah, because I think from your age, like your first mobile phone should be already a smartphone, right? I don't know what is your first phone, but in my age, my first phone is a very stupid old style phone, but it still cost me a lot. Okay, it cannot do anything. It just like have the black and white, very small screen, and it only can call someone and text message. But by that time, when I get that one, I already feel that that was very cool. All right, but then after 10 years, after 20 years, yeah, for that kind of phone, Nokia, I doubt that anyone heard this kind of brand before. I doubt. Yeah, actually, yeah. So, but that brand is I think the domain that the market, the mobile market, like 20 years ago. All right, but they no longer do this kind of thing because that when Apple announced their first generation iPhone, yeah, actually it already killed this kind of the very old style mobile phone. So this is kind of business recession. and then probably also kind of like changing development patterns. For example, like now everybody talking about, we need to go green, so that no longer, I think most of the government already set up some carbon reduction plan. So probably those electricity car will gonna dominate the car market in the near future. Okay, so every car manufacturer, they really need to think about what is the development pattern for them, whether that they use it goes to all electricity or go hybrid. Okay, otherwise they cannot really meet these kind of targets in the near future. So that it may be also caused by the consumer habits. Okay, for example, like now everybody like Tesla because they think Tesla is cool, Elon Musk is cool. So that they just try to buy the electric car to buy the Tesla. Probably it's not because that they want to go green. It's just that because they prefer to do that. Okay, they prefer to do that. Something like that. So now, if we also think about this, I also want to mention one of the example. Like this is just based on my personal experience. That I think I only bought one iPhone like 7 or 8 years ago, which is the iPhone 5S. Okay, this is a very small one, but I still really like it. Also, that now my daughter uses it, I no longer use it, but it still can be used and still can be function well. Okay, but then after that, I changed to Samsung. I mainly used the Note series. But do you know how many phones that I have been broken? 3. Just every time when I bought the Note, I think that is very good. Camera function, the Samsung Pen, S Pen, all the function I really like it. But the reliability is very, very low. Okay, it's kind of like after they passing 1 year warranty, there is just cannot really well function. All right, so that this is also caused me that, for example, if I want to resell it, you know that the salvage value of this is very, very low. But then you know that for the iPhone, if you just have a well-maintained, well-used it for 1 year, it still can sell a lot. I think probably you can sell at least like half of the original value that you pay. Okay, so that is now when you try to buy something. Okay, now so of course that this is not related to construction or not related to infrastructure, but like I said, so this kind of the concept you can really utilize in your daily life. Now, when you try to make a decision, you want to buy some asset for yourself. All right. So probably now you have 10,000. Okay, and Samsung probably is not as expensive as the iPhone. All right, and then but you say you may think about then I don't really need the iPhone. I buy another one. But actually, that kind of thing may cost you more because that if we only consider the initial investment, if we didn't really look at about the salvage value, the resale value, depreciation, we may really make these kind of wrong choices. But I'm not talking about that. I encourage you to buy an iPhone. No, not like this, not like this. But it's more like when you try to make this kind of decision, actually now you can take more information into account and then have a more comprehensive decision making. All right. So then when we talk about that, then we were gonna tell you that how can we really use the depreciation in the infrastructure, in the construction. So we can determine the decline in market value of the construction asset during a certain time periods. So this kind of concept we can apply because you know that for the construction company, they will own many different kinds of assets, especially the equipment. The equipment is very, very expensive. The crane, truck, etc. They are very expensive, right? So that they also will meet this kind of the problem that they will have depreciation. When after we also need to know that where is the useful life of them. We also need to say do this kind of evaluation, right? So that it also determines the depreciation amount to use in the replacement decision analysis. When should we replace the truck, or when should we replace the crane? Something like that we can think about, and then this is also the must-have in the infrastructure management. And it can also use to evaluate the tax reliability, the liability, and realistically reflects the asset liability of a company. Okay, so actually for the tax that the construction company need to pay, those assets will also take into account. All right. So now we will talk about three very basic depreciation accounting techniques that here. All right. So there are many, just many, but we just talk about something wide acceptance and very common in professional practice. The first one is called the straight line method. The second is sum of the year method, and also the decline balance method. All right. So that we will start it with some very important variables for depreciation accounting, that the value of the purchase price or the cost when new. Okay, so now you know how we can take into account is that we were gonna have this. It's just like the initial investment purchase price for the asset. And we also need to know the length of the economic life, like the estimated time that like the purchase and disposal or resale of the construction equipment. And we also estimated the salvage value. All right. So then the straight line method here is like the concept is very straightforward, just like the method shows. So it depreciates the equipment value equally in each of the year that the equipment is owned. Okay, and you also have the depreciation rate like this. We just take this R, okay, that is equal to the 1 divided by N. So the N is just the number of the years that equipment is owned. So it's just really depending on how long like this equipment we're gonna use. So we were gonna depreciate it equally every year. So then the annual depreciation amount that is equal to D is equal to the R times the bracket of P, the present value, purchase price, minus the future value. Okay, so that we can just do also like the equipment book value at the end of each year, like after the annual depreciation has been subtracted, so that the BVM is equal to the BVM minus 1 minus DM. All right, and the BVM is the book value in the year M, and the BVM minus 1 is the book value in the year M minus 1. So then the DM is the annual depreciation amount. So we can go for the first example and using the straight line method. So now the contractor purchased a plant for 250,000 and will use it for 6 years. Then the estimated salvage value is 60,000 using the straight line method of depreciation accounting. What is the annual depreciation amount and the book value of the plant at the end of the third year? All right, so that we just do this straightforward, like we have the annual depreciation rate, that the R, we just use 1 divided by 6, which is 0.167, okay? And then, so based on the D is equal to the R times the bracket of the P minus F. So now we have the depreciation amount annually, like the 0.167 is equal to the 250,000 minus 6,000, which is equal to the 31,666.67. All right, so then we have the book value like this. We have the first year, we were gonna get this 250,000 minus 31,666.67, which is equal to the 218,333.33. All right, and then we just do further that we use this the end of the book value of the year 1 to calculate the book value of the year 2. We have 280,333.33 minus 31,666.67. So we get the 186,666.67. And then finally, we will get the same for the book value of the year 3. We'll get 155,000. All right. So this, we already answered the question that we were gonna, at the end of the year 3, we will get the book value as the 155,000. All right, so then if we just do it more comprehensively, like for the each year, so we will gonna get the same depreciation amount for these 6 years. we will also can have the book value for each year like this. And finally, we're gonna get the book value of the end of the 6th year as the salvage value as the 60,000. Okay, 60,000. So that's good. So this is for the straight line method. So this is for the straight line method. All right. And for the next one, we call the sum of the year's digits, the SOYD method. So the annual depreciation rate differs for each year, and but it will gonna follow, okay, this the annual depreciation rate, which the RM is equal to bracket of n minus 1 plus 1 and divided by the SOY. So n is the number of the years that the equipment is owned, and also the m is a specific year in which depreciation is being determined. So, but the SOY here is the sum of the year, and it can be calculated like this. The SOY is equal to n times the bracket of n plus 1 divided by 2. Okay, divided by 2. So that we're gonna also get the annual depreciation amount as the dm is equal to rm times the bracket of p minus f. So we can just use the SOY to revisit the example 1. Yeah, all the information is the same. Okay, Michael, you answered a question that salvage value, is that salvage value equal to at the end of the estimating? Yes, I think it will be n equal to the n, because that when you calculate it based on that, the f already be the future value, which is a salvage value, so it won't be lower than that. All right, so Michael, yeah, so yeah, it will be equal. So that if we do SOY, then you can see that the sum of the year that the we first thing we calculate SOY, which is equal to n times the bracket of n plus 1 divided by 2. And then you will get the SOY for this example, which is 21. And the depreciation amount of this for the 3rd year, it will be done like this. We will based on this R1, R2, and R3, you will gonna get the R1 will be the 6 out of 21. And R2 will be 5 out of 21. It's just based on how we calculated based on the equation. So that for the R3, it will be 4 out of 21. And so if we do this and then year by year, we're gonna get the D1 is equal to the 6 out of 21 times the bracket of the 250,000 minus 60,000. Okay, minus the 60,000. So which is the 54,285.71. So that for the D2, then it will be equal to the 45,238.1. So you will look at about that, yeah, the depreciation amount actually for this method, the SOYD, will be different. But in the beginning, it will be depreciated faster, okay, because you can see the weighting is higher. Here is a 6 out of 21, but the second is reduced to the 5 out of 21, okay? So think about that. If if you also continue with the iPhone example, when you bought a new one, can you just resell it as new, like the price you pay? I think for like a couple years ago, when the market demand is higher than the supplier, this is possible. But usually, when you pay this kind of thing, yeah, if, for example, not iPhone, if you buy the car, new car, once it started to operate it, even that you only drive for 3 kilometers, okay, it will depreciate a lot already. Okay, so for the straight line method, to some certain equipment or like to the car is not suitable. Usually, that for those kind of things that it will depreciate it much faster in the beginning compared to the lower, compared to the following years. Okay, so this is all SOYD. We're gonna evaluate this kind of situation, and then so for the book value at the end of the 3rd year, we're gonna see here is that we were gonna use the BB1 equal to the 250,000 and minus 54,285.7. So we'll get the 195,714.29. All right. and then we're gonna BV2. So you can see that we will use this book value at the end of the first year to calculate the book value of the year 2. We're gonna have the 195,714.3 minus 45,238.1, which is equal to the 150,476.19. Okay, this is the book value for the year 2. All right, so it would depreciate it very fast in the beginning, but much lower than the coming year. So then you will also see here, then we can find that if we depreciate it like this, we were gonna have the lower depreciation amount. Like for example, here we have 9,000 something for the year 6, and then finally you will gonna also retain it as the salvage value at the end. Okay, end of estimating, like for the 60,000. So whatever the method that you use, keep in mind that the book value of the last year for the calculation will be equal to the salvage value. All right. And then another method that we're going to introduce is called decline balance, which is DB method, like annual depreciation rate, also applied each year to the remaining book value. And then annual depreciation rate, which is equal to the R, which is equal to the X divided by N. But the X can range from 1.25 to 2, just depending upon the degree of acceleration desired. So like I said, like different kind of equipment, different kind of the asset, they may have a different kind of degrees or a different kind of speed to depreciate it. So that this X can actually based on some kind of assumption. It's just like probably some expert which is really familiar with some certain equipment, then it can be determined. Or your company, if they have some previous record, they may also determine based on those kind of records for this X. And the N is still the number of the years that the equipment is owned. So the annual depreciation amount will be equal to the DN, like equal to the bracket of BVM minus 1 times the R. So the same thing. Yeah, I just want to use another, not another. It's just like we revisit the example again. But we assume that the X is equal to 1.5 for depreciation decline balance method. So that for this one, we were gonna find the R now is 1.5 divided by 6. So we're gonna get the 0.25. We're gonna get to 0.25. And the DM then is equal to the break of the BB and minus 1 times the R. So if we have a depreciation rate like 0.25, then we can have a depreciation amount, because how we get this 62,500 is that we just use the 250,000 times this 0.25. So that we minus this depreciation amount, then we get the book value of the after year, the first year. So we get the 187,500. Okay, so that we were gonna take this one and times the 0.25. So we get the depreciation amount for the year 2 as the 46,875. So we also use this 187,500 minus this 46,875. So that we'll get a book value of the year 2 is 140,625. All right, and then we just do the similar calculation for the year 3, year 4, and year 5. Then you are gonna find out like this. Okay, but then now until here, that if we use the 9,101.56, okay, if we just use this one times the 0.025, actually for the depreciation amount for the year 5 should be, let me see, should be higher, a bit higher. It should be 19,700 something. But why we put it 19,100 something? It's because that we need to follow the rule that the depreciation amount, okay, should not be larger. For example, the end of the value should be no less than the salvage value. So instead of minus the 19,700 something, we minus this which is the 79,101 minus this 60,000, which is resulted the depreciation amount for the year 5 is 19,101, not 19,700 something. All right, because we need to keep the end of the book value as the salvage value, which is 60,000 in this example. All right, so this refers to the Michael just asked. The salvage value should be equal to the end of the book value. Okay. So the depreciation ends just when the book value is reduced to the salvage value. So that is why you can also see that the depreciation amount for the year 6 is 0. Okay, it's 0. So we can see if we just try to compare with the 3 different kind of methods, you can see that, yeah, the straight line, of course, it's just like straight. But the sum of the year and decline balance, it will be just like depreciated much faster than the straight line method. So the straight line method just take an equal fraction of the depreciable value, and the SOYD just take a changing fraction of the depreciable value. And the DB takes an equal fraction of the current book value, and both the SOYD and DB, they just accelerate that the depreciation during the early years. So DB does not allow the book value to fall below the salvage value. Okay, so what's good with this one? Okay, so how about we have 5 minutes break? Okay, 5 minutes break, so that we'll continue with the course estimation. So please come back at 3:35. Yeah, because we need to finish this part, okay, so that you can really do the tutorial today. Yeah, and the course estimation part will be a bit challenging. Hello? Yeah, so, yeah, can you still see the screen? So let's continue for the cost estimation. Anybody there? Okay, good. Yeah, sometimes because for this one, I need to have some feedback from you. Otherwise, I don't know whether, yeah, the voice and the screens are okay. So yeah, then we keep talking about the increment appraisal, but then this part I would like you to fully concentrate it for the next 30 minutes. All right, because I think this one is kind of like a very integrated part for those things that you learn, that how you can apply it to those equations to really do cost estimation. And also we will utilize the depreciation here. All right, so that for this part, we were gonna also tell you that what is the cost estimation, and then we were gonna split, like categorize it into the ownership cost and the operating cost, and then finally we can determine of the unit cost. So then, for the construction equipment, it must earn the sufficient revenue to cover the construction investment costs, right? Yeah, otherwise, how they want to buy the equipment? Of course, the equipment do something, and then the equipment can help the construction company to earn money, right? But then, if they want to do such kind of investment, they really need to know that, okay, when they own this equipment and also the operating, when they operating that, it will also have some certain cost. So that if we separated that, the contractor must be able to estimate the ownership and operating cost for each piece of the equipment, because things that the different equipment, of course, that, like I said, depreciation, different equipment, they have different kind of characteristics. Okay, some equipment need to be well maintained. All the equipment should be well maintained, but they probably have a different kind of the method to do that, or they can decide that, okay, whether this kind of equipment they should buy it, or they should rent it, or lease it. Okay, so that it will kind of a different kind of decision making. Okay, during operating operation of the company. So the costs are used to determine that the rate to charge the project for the plant equipment use, of course, right? So that they can make a decision regarding disposal, purchase, rental, or lease of the equipment. So that, yeah, based on this, then now I think for the following, not today, but in the following weeks, then you will understanding that why we want to start it with this, because of for those construction project, infrastructure projects, okay, when you break it down into some small task, and then those tasks which can be definable, then you will identify that, okay, for that kind of task, we can utilize this equipment, how many people that you needed, material that you needed, so that this is kind of a button approach, so that a company can really determine, okay, for this tender, okay, what will be the cost, and then so that they can beat that kind of projects, okay, from the government, from the owners, something like that. So this will be kind of like button-up approach we will talk about, so that you can really do the whole cost estimation, not only for the equipment just one part of that, but the idea will be exactly the same. It's just like we need to identify all the details first. All right. So then now we'll talk about ownership costs, like which are incurred whether the plant is used or not. Okay, once you own the car, for example, even that you didn't really drive it, okay, the age of the car will be also cost the depreciation. Remember that? And then it will also depending on where you store it. So that's for the construction equipment. Even that, if the company didn't use it, idle there, it will still have the cost. So, but what will be the cost? We will talk about later. And then for the operating costs, they are incurred only when the equipment is used. So the ownership cost can be, for example, depreciation, interest rate that you need to pay, taxes, insurance, storage, license fee. All right, so that if you own your personal car, this is also the things that you need to pay. Your house, your apartment also need to pay this kind of tax, insurance, a lot of things, even that you don't use it. All right, and for the operating costs, maintenance and repair, tires, fuel, service, downtime, and operator. So these are all the things that we need to consider. Okay, so that we were gonna go to the detail and calculate it based on these kind of categories one by one. All right, so that's why I really want you to really pay attention for that. So then for the ownership costs, they are best estimated by the time value of the money analysis method, which you already know. And the contractor will know the purchase price and must estimate the ownership periods, how long you will own the equipment, the residual salvage value, the final value, the future value, like after depreciation. So that this information will also accounted for depreciation. All right. So then here, I also want to show you some table, because that for this kind of explanation that the different, I would say the equipment manufacturer, I don't know whether you ever go, probably you have the internship, right? You go to or probably you go to some job site, construction site, you will see that those equipment, it can be CAT, Caterpillar, Volvo, Mitsubishi, or other kind of thing, right? It's like different kind of brand. So that actually those manufacturers, they provided this kind of table. For this one, actually is provided from the Caterpillar, the CAT, and they actually are also updating this kind of information every year. But this is just, I want to show you example like this table. So this is the operating condition that they can tell you about the estimated useful life of the construction equipment in the total operating hours. So that once your company want to buy, and so they can look at about those kind of guideline or the handbook they provided from the manufacturer. So if they want to buy the crawler tractor from the Caterpillar, then they can have the sense that, okay, if they bought this, it will gonna be used in the average condition should be 12,000 years. 12,000 hours, not years. 12,000 hours. And then for the grader, it will be in average like 50,000 hours. Excavator, 12,000 hours. Hauler, scraper, track loader, wheel loader. So you can see that different kind of equipment, they also have a different kind of useful life. All right, so this is also very important that this is kind of information that you need to get. Okay, so that for this ownership cost, you also will include interest, taxes, insurance, storage, and also like license costs are used to be estimated the minimum attractive rate of return. So remember that why the company need to set up their MAR is because that like all of like these kind of things. All right, like interest is kind of charge and borrow, or the return expected from the invested money. Okay, like taxes, when you bought that equipment, the asset, you need to pay the property taxes, and also pay for insurance, like for the general liability insurance to cover the damage or injury caused by the equipment. Okay, of course, you have the construction workers work on the job site, and if you don't have the insurance and then suddenly some accidents happen, the company, of course, will lose a lot of money. So that for this kind of liability insurance, I think it's a must to have for those equipment. So there's like, even that you own a car, general liability insurance is that you must to pay. And then some other kind of things that you may need to pay is like kind of the collision for corrosions for equipment insurance to cover the physical damage to the equipment. And so for storage, is the cost of the protecting the equipment when not in use on the projects. So also the license costs, like we pay for a place and other use permits. All right. So that now, how we can take all this into account? I just give you a very, I won't say this simple example. For those examples that we'll kind of talk from now, it will be much complicated than what example that we just shown, okay, like previously. So that for this one, a contractor just purchased the crawler tractor. So now you have the information, crawler tractor for 155,000. So how can we know that how long, like what is the end? That because now we want to know the useful life, right? So for this crawler tractor, we probably can refer it to this kind of page. So crawler tractor in average condition, then we know that, okay, for this equipment, it can be used for 12,000 hours, right? Can you see that? Like average condition, 12,000 hours here. Okay, and then you also have the information, for example, here, like the annual usage will be about 2,000 hours. So the salvage value at the end of the tractor's useful life is estimated to be about 12% of the purchase price. So based on those things, you can know that, okay, then what it will be the salvage value. Now we can use the purchase price, 155,000 times this 12%. So you can get a salvage value. But how long this equipment can be used? Remember that we get the 12,000, right? 12,000 hours. We can use these 12,000 hours divided by these 2,000 hours. So we can estimate that, okay, this crawler tractor actually can be used around 6 years. Makes sense, right? So this is how we define the end. And then here for the example one, we also have the contract estimated that the ownership cost factor to be interest 9%, taxes 2%, insurance 2%, storage 1%, license fee none. So what is the estimated annual ownership cost if it is operated under the average condition? All right, so that we have a quick solution here that we have expected useful life 12,000 hours. Remember that from table 4.1. Crawler tractor in average condition, we get 12,000 hours. So we can have the period of the ownership. We have the 12,000 divided by 2,000, so it should be 6 years. And then we can also define the minimum attractive rate of return, which is sum of those administrative costs. That we have the 9%, 2%, 2%, and 1%. So the MAR here, we assume that can be 14%. So then we can also have a simple cash flow diagram like that. We have initial investment, 155K, and also times this 12%, which will be the salvage value equal to the 18,600, right? 18,600. So far so good until now? Then we can have the present worth of the salvage value. Like here, we can convert the future value. Like the P is equal to the 18,600 times the bracket of the PF, 14, 6. So we get 8,481.6. And we can also subtract the present worth of the salvage value from the purchase price. So we get this 146,518.4. And then we can convert this P, okay, we can convert this P to annual value. Remember that for these kind of construction equipment things, like for the cost estimation, usually we were gonna convert it to the hourly rate. Yeah, so that we can easily to compare and easily to know that, okay, once we use this equipment for 1 hour, what will be the expected cost that we're gonna pay, all right? So that we can convert it to an annual series, like the A is equal to 146,580.4 times the bracket of the AP, 14%, 6. So we finally get the annual value is the 37,655.23. And then we can get the cost per hour. Now it's just further divided by 2,000. So it should be $18.83 per hour. All right, so this is the kind of the ownership cost. So I probably can also ask you another question. So this is the kind of process. Can we use other kind of process to calculate that? Of course. For example, like here, we can't convert this future like salvage value to P. And then we have the P because we have initial investment and minus its future value to the present value. So we have the net present value. Okay, but actually what we can do is also directly like convert this P to A and also convert this A to A. Okay, we still can get the same A as the 33,655.23. You can also try it and the answer should be the same. So why I want to give you this idea is that for this kind of calculation, you will be lots of different kind of things. You just think about the easiest way or the most comfortable way to calculate it that. But you need to make sure that the target is what we want. For example, when I ask you about the ownership cost for this equipment, and of course, I don't mind that how you convert it, whatever you like. But then finally, it should be an A. Okay, so that if you don't believe it, you can just further try that different kind of the way you will get the same answer. Okay, so then further now we will talk about operating costs. So the best source of the data for estimating operating costs is also from the historical records. Okay, so for example, that if you're a company, of course, if your company has been wrong for like 20 or 30 years, so they should have the record that okay, for the crawler tractor, how long they can be used, and then what is the fuel price, and then what will be the condition, what should be replaced. You will have all these kind of historical records. But if not, the next best sources is just use the cost factor that provided by the equipment manufacturers. Like I just say that, some company, some contractor or manufacturer, they may have their own, I would say, those cost factors for their equipments. All right. And then operating costs then are greatly influenced just by the age of the plant equipment and the state of the repair and also the operating conditions. So now we're following to talk about that. How can we really calculate it? This one by one. We'll talk about maintenance and repair. Also tire. Tires is a very tricky part, and I will introduce and I'll tell you why later. It's because that the tires has a different useful life compared with the equipment itself. Right? Think about that. If you own a car, do you think that your car, if you want to drive for 10 years, you can use the same set of the tires for the 10 years? Of course not. You need to replace it probably several times, also depending on how you drive it. Okay, so that's for the same for the equipment. If they have the tires, of course, we need to use the separated cash flow to really take this into account because the tires have a different useful life compared with the equipment itself. All right. So then we also consider about fuel. Of course, fuel cost is also very important because when you drive car, of course you need to have the fuel. And so there's for the construction equipment. So the equipment can be also kind of like diesel engines, can be fossil fuel engine. It's just like have also different type. So that fuel is also one of the factors that we need to consider. Also service, downtime, and also the operator. So then we started with the maintenance and repair, like roughly estimated by using percentage of the annual straight line depreciation amount. So here is the part that we really need the depreciation. Okay, so we just talked about that, right? But then for this kind of cost estimation, for the equipment, we will mainly use the straight line depreciation. All right, just a simple assumption. Okay, and for the following table, we also provide a factor that to be used to estimate the hourly maintenance and repair costs. And since the factors are based on the 10,000 operating hours, they must be adjusted based on this. The hourly repair cost is equal to the RF, which is the plant equipment repair factors, and times the useful life in hour, and also times HDR, which is hourly depreciation rate, and divided by 10,000 hours. All right. So then here is table 14.2, like indicated about equipment repair factors based on a 10,000 hour useful life. And then this table, I think it's kind of like a references. Actually, is from the Terex Corporation, which is the top 10 car contractors in the United States. I'm not quite sure that. I think the contractor, those international contractor, big company, even like in Hong Kong, they should have this kind of information, but I just couldn't get it. So I just use this as the example to demonstrate it. But how we do it, how we refer it is totally the same. And then here we just see that the equipment will be listed here, like the button down, crawler tractor, how they're loaded scrappers. They should also less tires. They can just based on operating condition, they will have different kind of percentage of the repair factors. Okay, like based on the hourly straight line depreciation amount. All right. So that for the tire costs, they should be treated as a separate operating cost, like they have a different useful life than the equipment. So the track replacement for the track mounted equipment is included in the maintenance and repair cost because they don't have tire, right? So the tire are subtracted from the purchase price when determining the ownership cost. Here is also a small part that you really need to be reminded. It's like, remember when you bought those equipment, if we want to calculate it for the estimation, the first set of tire need to be subtract because it already need to be counted as a separated cash flow. Okay, so you need to really take out, subtract it for the first set of the tire. All right. And then the separate cash flow is performed for the tires, so that we can use another table to estimate the tire life, which is the table 4.3, and data and tire costs, and develop the cash flow analysis. And then we also need to think about the tire maintenance and repair costs, which is around the 15% of the hourly straight line depreciation for the tires. All right. So then for this table, is also provide the tariff corporation. You can see the estimated average tire life in the hours of use. For example, the bottom down in average condition should be 5,000 hours. Greater in average condition is 2,300 hours. It's just based on that. You need to find out those kind of information that you needed. Okay. So then the next one, we have the fuel consumption, like the rate of the fuel consumption for the plant and equipment varies with the rate of horsepower, duty cycle of the engine, like the percentage of the time. The engine is operating the maximum output, which varies each piece of the equipment and also the operating conditions. All right. So the hourly fuel cost we will take into account, like the flywheel horsepower times the fuel factor and times the fuel cost. So that here we are also referred it for some tables, and then this one is provided by actually the government thing like pretty office. So if we have the equipment fuel factors in gallons per horsepower per hour, it's like just like this gasoline, diesel, and have a different kind of equipment, we will have a different kind of factor. All right. So the services for the filter, oil, and greases and just costs are estimated as a percentage of the hourly fuel cost. So for the equipment service factors, it's just like a percentage of the hourly fuel cost. In favorable condition, it should be 20%, average is 33%, and unfavorable is 50%. And the downtime is just considered by using an operating factor when determining the productivity rates. All right, so you know that the equipment cannot be used just like every minute, 24 hours per day, 7 days a week, right? Because even the driver, the equipment driver, the workers need to have the rest. So of course, there should be some downtime for those equipments. And the operating factor is a percentage like equal to the actual numbers of the minutes per hour, like the plant and equipment is working and not idling. So usually we can say that, okay, if the worker or driver needs some of the rest, we can have the 45 minutes per hour, then the downtime will be 0.75. Okay, it's kind of like efficiency estimation for using construction equipment. And of course, we also must be estimated using some local wage rates and the fringe percentage for the labor cost. Okay, so labor cost should be equal to the hourly wage rate and plus the fringe benefits. And like the benefit can include the vacation, retirement, insurance. All right. So now after you know those kind of concepts for this theoretical part, now we will have a very, I would say, comprehensive example to do cost estimation. Okay, so please keep in mind, I think I can finish this around 20 minutes, but please pay fully your attention for this. Okay, so we will start it like that. And because we also kind of separate it to the ownership cost and operating cost for that. So for information, a contractor has purchased a wheel loader. Now you know what this equipment is. And for 114,000 and plans to use it about 2,000 hours per year. And the contractor anticipated disposing of the loader after using it for 60 years and realizing it a salvage value of the 35,000. And tires for the loader cost 4,000 for a setup before, and the brake horsepower rating of the loader's diesel engine is 105 horsepower, and the operator will earn the $34 per hour, including the fringe benefit, and the diesel fuel cost 1.2 per gallon. All right. And the minimum attractive rate of return is 12%. Now you also know the interest rate and what are the contractor's hourly ownership and operating costs for the loader. All right. So that, like I mentioned in the very beginning of this when I introduced to this subject, calculation part easy. I mean, there's not much very complex calculation processes, but for the question itself, for the information, yeah, it will be a bit difficult because you need to have more like a very like comprehension to understand it, all these questions and then extracted those information that you needed to fit it with those equations. All right. So that we will study with this one by one. And then we will start it with the ownership cost for loader. And we have a purchase price less the tires. Remember that? We will have the separated cash flow like between the equipment and the tire. So the first thing we were gonna minus 4,000. And we have the cash flow diagram like this. We have the annual ownership cost like this. We have the A is equal to the 110,000 times the bracket of the AP common 12% common 6. This 110,000 is the initial purchasement, subtracted the tires, right? So we convert this purchase price to A. And also we minus, because now we want to focus on the cost. So we minus, which is a salvage value, like 35,000 times the bracket of the AF common 12% common 6 after 6 years. So we convert this F directly to A. All right. So then we can get this 22,425 per year. This is the annual cost. And we have the hourly ownership cost like this. We all further divided by 2,000. So we have $11.21 per hour. Right. So this is the $11.21 per hour. So this is for the ownership cost. How about operating costs, right? So we will also talk about this one by one. Like, so we have the repair cost first. Remember that, and we can have the hourly straight line depreciation amount. We have the 110,000 minus this 35,000. So this is the purchase price P minus the future salvage value. So we can also divide it by how long we're gonna use it. We were gonna use 2,000 hours for 6 years. So we were gonna get the 12,000 hours. So we will get this depreciation amount, which is 6.25 per hour. Right? So 6.25 per hour. So we have the hourly repair cost based on equation 4.1. We have the favorable condition. For this one, I think so many students ask me how we can determine that, okay, whether this is the favorable condition, average condition, or whatever. I will tell you that for this subject, there's no 100% correct answer because that those things that we need to have the assumption. Okay, for example, if I didn't mention that during a test, during an exam, you can do whatever assumption that you want. You can be favorable condition, average condition, but you need to tell me that, okay, then this is your assumption that, and then you put the number here, all right? And then so that for this one, we also times the 12,000 and times the 6.25 divided by that 10,000 because of the adjustments, okay, like based on HDR. So finally, we can get the repair cost of $3.375 per hour. So far so good. So this is for repairman. And then for the tire replacement cost, you can see the tire life in the years in the table 1.3. We can have the, in average condition, we get the 32,000 hours for this equipment. And we divide by 2,000 hours per year. So means that we expected that the tire need to be replaced 1.6 years. Okay, need to be replaced every 1.6 years. So that we can have these separate cash flow. Initially, we pay 4,000, the first set of the tire when we bought the equipment, but we need to replace it after 1.6 years. So we have the P1 equal to the 4,000 times the PF common 12% common 1.6 we need to have the third set of the tire, P2, equal to the 4,000 times the PF, common 12%, common 3.2, and also the fourth set, like P3, the 4,000 times the PF, common 12%, common 4.8. So that we were gonna find that, because we cannot really find this kind of number for the n for 1.6 like decimal, right? So that we can not really find it directly, but we can do interpolation. For example, like here, for the first year, we get the 0.893, and the second year is 0.797. So for the 1.6 year, it should be a value between these two numbers, right? So then we're gonna get it, just use the linear interpolation method, like the value y can be found through the following equation. We will get the capital recovery factor of the 1.6. It's just like this. We have the 0.893 plus the bracket of the 1 plus 6 minus 1 times the bracket of the 0.797 minus the 0.897 and divide by 1. And then so we will get it this. The value should be equal to the 0.835. So remember, I already mentioned several times about this linear interpolation method. You can just follow this to get those kind of value. All right, even for the IRR, you can also do that. Okay, just do linear interpolation. Or we can use the equation, but I think this is the least preferred. I would like to mention. I would still prefer you to just use the function notation. And so for this one, we were gonna get it, but we still can do that here. So the present sum is equal to, just like the P is equal to future sum, like times the bracket of the 1 plus I to the power of negative n. So we will have the P0 4,000, P1 equal to the 3,336.65, P2 to 27,083, and P3 2321. So we're gonna get the P for a tire for the fourth set of the tire equal to the 12,441.71. So that would convert it again from this P to A. We were gonna get the annual cost for the tire is 3,023.34, and then further divided by 2,000, we get a tire cost per hour should be equal to the $1.51. So far so good. So this is how we get the tire cost. And don't forget that the tire also need to have the maintenance and repair costs. We will gonna get also further times this 15%. And then depreciation amount is equal to 4,000 divided by the 3,200. So we can get the depreciation amount is 1.25. We get a time maintenance and repair cost, which is 0.15 times 1.25, and is equal to $0.19 per hour. So the total hourly operating cost for a tire is this 1.51 plus 0.19 is equal to the $1.7 per hour. All right, so this is for the tire cost. And the following is about the hourly fuel cost. That we can get a fuel cost, which is average is the 0.036. Yeah, also based on the assumption. And the hourly fuel cost, then we know the horsepower, we know the fuel factor, we also know the fuel cost. Then we have the 105 times 0.036 and also times the 1.2. We got the 4.54. This is the fuel cost. Okay, this is the fuel cost per hour. And for the filter oil and the grease hourly cost, then this equivalent service factor is at average condition is 0.33. We just use the 4.454 times this 0.33. Then we can get the hourly service cost for the fuel filter and the grease hourly cost as the $1.5 per hour. All right, it's almost the end. Then you can now find that the total operating cost for the loader. We have maintenance and repair for the 3.375. We have tire cost 1.7. Already considered repair, right? And also the fuel cost as the 4.54, and also the filter oil and grease as the 1.5. Operator cost, it already give it in from the question. So that with some subtotal of them is the 45.115. So far so good. So this just shows about the operating cost. Then we will also need to remember to add up the ownership cost, which is 11.21. So finally, we will get the total cost that when we want to use this machine, it will cost you $56.33 per hour. So that's good. Yeah, probably for some of you, it's a bit difficult to really absorb or understanding of them. But yeah, highly recommend you to also refer it again. Yeah, and also that you will also get some practice in the tutorial. And then don't worry about that. For a tutorial question, it should be, yeah, it's easier than this one. It's easier than this one. And so finally, we also want to calculate the unit cost determination, that the cost per unit of the product. For example, the unit cost should be equal to the hourly ownership and operating cost divided by the hourly production rate. So we can determine the productivity of the several pieces of equipment at a later time. And the hourly cost can be used in conjunction with the equipment productivity estimated to determine unit cost for elements of the work. So like this. Assume the loader can load, yeah, because we just talked about loader, right? For if the loader can load the 120 cubic meters of the aggregated per hour, think about, yeah, probably we want to do some foundation or something like that. So that loader can just do this kind of aggregate per hour. And what is the unit cost of the material like handling by the loader? So we can just simply calculate it like this: 56.33 divided by 120. So it means that this will cost you, if you want to handle this aggregate, it will cost you $0.47 per square meter. Per cubic meter. Per cubic meter. So this is how we can do for the cost estimation. We can know that if we want to use some certain kind of equipment, what will be the cost? What will be the cost for an hour? And we can also further to know that, okay, if this kind of equipment can be used for some certain work, and then what will be the handling productivity and what will be the benefit that they can really bring. All right, so that's good. Okay, so if not, I think I will end of my lectures today here. All right, and then the following part, you can have a 10 minutes break. And our teaching assistant, Bahi, will lead you to do the tutorial. And you can find out there will be 3 questions from tutorial. The first one is about IRR. The second one will be depreciation. The third one will be cost estimation. All right. So it's just like cover what we just learned today. And yeah, you are expected also finish these 3 questions by 5:30. And then you can upload it through the Blackboard, that what we did last week. All right. So I will also take this opportunity to say Happy Chinese New Year to you. And then we will resume our lecture after the Chinese New Year.
Hey everyone. So if you have any questions, can you hear me? If anyone, oh, okay, thank you. So let me know if you have any questions here. So, like I said last time, the best thing to do is to first draw the cash flow, draw it and look at it visually. This is going to solve lots of your problems. So let me know if you have any questions and if I can be of any help to you. To those who are listening and who are watching the video and who are still in the class, let me perhaps show you one by PowerPoint, and it's going to be easier for you, I suppose. It's going to be easier. Hmm. So it's 8 years, right? So it's 8 years, and in the beginning year, a contractor is considering making a $300,000 investment. So the contractor invests a huge amount of money at zero, right? And it is gonna be $300,000. Then he estimates that his annual costs would be about 60,000. Okay, then let's draw the costs here. This is for 8 years. And the costs will be 60,000. And there will be about 115,000 annual income, right? So let's also draw the income. It's about 115. $1,000. So this is a fairly simple problem. If you have any question about it, please do let me know. I remember you had more questions in the class. What happened to you? Feel free to ask any question anytime you want. So I assume the first question is quite easy, and you should have been able to solve it by now. And it's fairly easier than the other questions. So let's talk about the next question. Next question is exactly similar to the examples that the professor showed you in the course material. Uh, there will be some equations to calculate the depreciation amount, and just remember that key rule: the book value shouldn't be less than the salvage value. That's it. And yep, again, let me know if you have any questions. So, hey everyone, a friend of ours asked a question, and I want to reply to his question, and let's see if I can be of any help. So, his question or her question, sorry, I am not sure about names. His or her question is that why do we, in lecture 2, example 10, slide 90, uh, what happens to this $750? So what happens is that first, this $750 in here is shifted forward to the 10th year by this factor here, as you can see. And then the present value of, okay, let me see. Okay, let me see. Why? Okay, maybe I got something wrong. I will get back to you soon about the question. Okay, so that was a misunderstanding from my side. There is a 6% annual growth rate. So for the 6th year, which is here, we have this term. We find the present value based on the future value with 12% rate and 6 years. For the 7th year, it will be 750 times 1.06. This is the growth rate. Again, the present from future value term. And for the 10th year, this one here is 750 times 1.6 power 4. And again, we have the similar term, but for 10 years. The student has asked, why don't we use annual equivalent based on the future value? Because if we use annual return, annual equivalent based on the future value for this 6th year, the only that annual representation would be the annual representation of year 1, 2, 3, 4, 5, and 6. But that's not correct. Our timeline is 10 years. Similarly, if we use that formula for year 7, we will have the annual representation for years 1 to 7. So that's why we need to find the present value of these costs or whatever they are, and then compare them together. So for the question from Michael, I think Michael Wong, Chung Kong. Okay, I apologize if I didn't pronounce it correctly. So the answer is yes. We need to convert the useful life from hour to year. Otherwise, how else can we find the lifetime? That's it, like 16,000 hours of operation. And then, yep, it will be 2,000 hours per year, then which is going to be about 8 years. And about the next question, for question 3, do I need to pay tires cost at the beginning of the first year? Usually, yes, but let me check the question again and tell you the exact right answer for this example, for this exercise. Yes. I think we should also we pay for the tires in the beginning of the first year, right? That's the valid point. So what is the question? The question is how you can convert it to the present value. No, not. Why do you want to when do you want to multiply it by 8? First, you need to find out how much you're gonna pay each year, and then you will need to find the present value of those annual costs. Did you get it? Could I answer your question? Yes, that's right. And about the other question, that does the greater cost include the tires? Let me check. If the question has not mentioned it exactly, you can assume that the costs of the whole grader or the whole machine includes the machine itself and the tires. And if you write your assumption, then it should be fine. So no worries about that. I would recommend everyone to pay attention clearly to the third question. It is one of the most important parts of the whole course. You really need to learn every single detail. Yep. I think you got what I mean. Since this is a very important question, I think I'm gonna write down the steps for you guys, and then you can probably think about it and check if you solve correctly, or probably you can write them down and use it for future. Although the professor has solved them exactly and clearly in the example. So the new grader costs $1,200,000 and is expected to have a useful life of 16,000 hours of operation. So it means 8 years, right? And we will have the purchase is about $1,200,000. So the first step is finding how much actually they have paid for, or we should pay for the machine itself. So it will be the purchase minus tires minus the present value, present worth of the salvage one, right? This is the first one. And then you should solve you should consider tires. How many times they are gonna replace the tires? Based on the question, they will have to replace the tires every 4,000 hours. So it will be they're gonna replace the tires 4 times. Tires replacements. Year 0. It means in the beginning of the purchasing of the machine, and then it's gonna be year 4, year no, year 2, year 4. It means every 2 years, right? No, let me check. What am I doing wrong here? And then 6. So nothing wrong. So they're gonna buy a new set of tires, but at the beginning of the 2nd year, at the beginning of the 4th year, and at the beginning of the 6th year. They're not gonna buy any tires when they're gonna sell the car. Who's gonna buy new tires for a car that is gonna be sold to someone else? So this is the second part. You probably need to use the present value of those costs. And the next part will be finding the annual costs, right? The major repairs will be needed after 8,000 hours of operation at the cost of $60,000. So at year 8, $60,000. What else do we have here? Minor maintenance, fuel and oil, it will be about $152.50 per hour. So for each year, it will be 100 times 2,000 hours, right, of maintenance. What else do we have here? Estimated salvage value. We already used the salvage value here. And yeah, pretty much that's it. Did I miss anything? To those who are listening to me, did I miss anything? Oh, yes. Yes. This is year 4, not year 8. You are correct, my friend. Thank you for noting it. So the only trick here, the only issue here is that you need to consider tires and think about them separately. What do you mean by how about at year 8? So in these type of questions, they usually do not consider repairing the machine before selling it, or before just putting it out. So no major repair at year 8. For the option B, I want to highlight this important point, that if you remember from the last session that we talked in the class, the timelines should be equal. The first one has 8-year horizon, but the second one has 4 years. So you need to repeat it 2 times. Or you need to repeat it another time, so it will be 8-year. We're gonna finish the class at 5:30. Please do let me know if you have any questions. No, I think Professor covered this concept in the. Let me show you the. Yes, slide number. Oh, in example 2 of lecture 3, he has proposed that you should use interpolation method. Please check example 2 of today's lecture. Yes, the question in short is yes, that $750,000 include the tire as well.